now we're going to look at continuous probability distributions, and there's two main distributions that we're going to look at. The first one we're going to see is the uniform distribution, and then more importantly, we're going to spend the rest of the time in the normal distribution. So a normal probability distribution has to be symmetric. It is bell-shaped, and it's described by this equation. So that's the normal probability distributions. Many would rightly say that this is the most important probability distribution in all of statistics and probability theory. The uniform distribution is also symmetric. It's not bell-shaped. It is values that are spread evenly over the range of possibilities. And it looks like a rectangular flat on the top. Okay, so we can do the same thing. We're not going to do a couple examples with uniform. To figure out the probability of a uniform distribution, we go to Calc, Probability Distributions, Uniform. And in this case, we only have two possibilities. We no longer have probability. We have cumulative probability or inverse cumulative probability. And for these problems, we're going to use cumulative probability. Remember, we use cumulative whenever we're using greater than or less than. So we're trying to find the probability that x is greater than 10. So we enter in the lower, we're told that the lower limit is 6 and the upper limit is 12, so we enter in those values. Our input constant is 10. Now remember, with the binomial and the Poisson, if we were talking about a counting number greater than 10, that next number was 11. But that's not the same thing with measurements. In 10, the number greater than 10 is 10.00000000001. It's so close to 10 that greater than or greater than equal to 10 mean the same thing. So we're actually going to just be subtracting 1 minus the Minitab answer when we put in the input constant being 10. You've got a couple examples in homework and a couple examples to look at in the book, and we're doing very little with the uniform distribution, the normal distribution. A density curve is the graph of a continuous probability distribution. It must satisfy the following requirements. The total area under the curve has to be equal to 1. Note the area under the curve, it corresponds to the probability that we're going to be looking for. The standard normal distribution is a special normal distribution which has the following special properties. First, the mean has to be equal to 0 and the standard deviation must be equal to 1. Finding areas and probabilities for normal distributions, we can use table A2. Again, we don't use the table very often, but it's a table back there for you to look at. Or Minitab, and we're going to do 99.9% of all our problems with Minitab. But if we wanted to use the table, you need to first convert a normal distribution with a given mean and a given standard deviation to the standard normal by using the z-score. Do you remember the z-score from chapter 3 that said z is equal to value minus mean divided by standard deviation? Then you look that up in the table A2. The table always gives the area to the left of the z-score. That's known as the cumulative area. And that's that's equivalent to the probability that z is less than or equal to that value that you looked up. Probability distributions. Remember what we see binomial there, we see Poisson there, but we also see normal. We're going to select the cumulative probability if we're trying to find probability that x is less than or greater than some value. And then in a little while, we're going to get to examples when we're using the inverse cumulative, and that's going to be when we're given the area shaded or we're given the probability, and we want to find what value of x is there. So there's 3 types of probability problems. First, we have a less than problem, and that means we're looking for the probability that z is less than some number. This is equivalent to the area under the density curve to the left of A. Less than, the numbers to the left are less than numbers. And then the answer is the answer directly from the table or directly from Minitab. So let's look at an example. Suppose I'm trying to find the probability that z is less than negative 0.25. I go to Calc, Probability Distributions, Normal. Select Cumulative Probability. It should default where the mean is equal to 0 and the standard deviation is equal to 1. If you have changed it for whatever reason, let's say during a test when you're going back and forth between standard normal and regular normal, you might have to remember to change the mean. If you're looking for the probability of a z, that means the mean is 0 and the standard deviation is 1. Your input constant is negative 0.25. And then hit OK, and Minitab says the answer is 0.4013, or about 40% chance of seeing a z value less than negative 0.25. Problem is the greater than problem. Probability that z is greater than some value. That's also the area to the right of A. In this case, the answer is 1 minus the answer from either the table or Minitab. Let's look at an example. Suppose we're looking for the probability that z is greater than 2.33. Calc, Probability Distributions, Normal. Select Cumulative Probability. Make sure the mean is set equal to 0 and the standard deviation is set equal to 1. Enter the input constant, and it is 2.33. The answer comes out to be 0.9901. Subtract that from 1, because the 0.9901 is the area less than to the left of 2.33, or the probability that z is less than 2.33, and we're looking for greater than 2.33. So the answer is 0.0099. The third type of problem is between two values. So then we're going to do the Minitab problem twice. First, we're going to do it for the larger value, the b, and then we're going to do the same process again for a, and then we're going to subtract those two answers. Probability that z is between -2 and -1. So the first thing we're going to do is do input constant being -1, and I get 0.1587. Then I'm going to go back to Calc, Probability Distributions, Normal, and I'm going to put the input constant being -2.00, and I get 0.0277. So the area in between those two values, or the probability that z is between those two values, is the larger value minus the smaller value, and I get 0.1360. I think it's a good idea to pause the lecture for a minute, go to Minitab and try these three examples and make sure you get the same answers I did, and then come back. So now we're going to continue on, but now we're going to be looking at the regular normal distribution, which is in real life what happens more often. There's two possible methods. You can use Minitab, and all you have to do is change the mean and the standard deviation. Or you have to use the formula, and then you have to, by hand, convert all of the values back to their z value, because the table in the back of the book, ed2, is a standard normal distribution. Everything has to be converted to z's if you use the table. The probability that x is less than 115. We go to Calc, Probability Distributions, Normal. Suppose it's given that the mean is 100 and the standard deviation is 15. So make those changes in the box. Input 115, and the answer is 0.8413. Okay, now let's look at the opposite. Let's look at, given the probability, find the value that corresponds to it. So I'm told that I want to find which value, which IQ score, separates the top 15% from the rest. So I go to Calc, Probability Distributions, Normal. An IQ score is a value. When you're looking for a value, you use inverse cumulative probability. When you're looking for a probability, you use cumulative probability. Enter the mean being 100 and the standard deviation being 15. Now, Minitab always wants you to put in the value, the amount shaded to the left of underneath the area density curve. Or if 15% is in the top, then 85% is in the bottom. So that 0.85 is what we put into the input constant, and it tells me that the top 15%, which is percentile 85, is 115.55. Lecture. We're going to continue on with this lecture of 6.3 and 6.4 in another lecture. If you want to, you can stop now, though, and continue and do the homework for 6.1 and 6.2, and then come back and listen to the lectures for 6.3 and 6.4. If you do not understand 6.1 and 6.2, you're going to you'll have a lot of trouble with 6.3 and 6.4. So it might be a good idea to stop now, go do the homework and on the My Math Lab website for 6.1 and 6.2, and then open up the next lecture for 6.